once every show, we try and have a more reflective session, a more relaxed session. And some of you know me, some of you have seen me progress. I actually teach people how to make designs beautiful. I am not at Leeds University, who will teach you how to make it work. I'm at the Royal College of Art. I teach performance sportswear design. I'm in a very fortunate position. But the people who know me realize that I don't have a grasp on the technical developments. And every so often I bump into a person who educates me. Now, Mark Taylor does it on a very regular basis, but I just can't listen to Mark Taylor the whole time. I've got to take other opinions in. And I bumped into Ramesh, and I suddenly thought, he's a really important person for a brand, the brand that owns Polartec, not even Polartec, and he wasn't trying to sell me Polartec. He was trying to make my knowledge level better. And he suddenly made it make sense. So we're going to, in the next half an hour or so, try and have a conversation where I'm going to try and get him to reveal this whole question that this industry is facing on the move away from fossil fuels to what is the alternative. And one of the suggested alternatives is bioplastics. And as I said in the introduction, a bioplastic the consumers have got hold of, and they are yet to work out it's not biodegradable and it's not plastic. So we're already using terminology which is confusing the customer. But that's enough about me. Ramesh, can you actually tell them what you do as a job? What you're meant to do as a job?
So my name is Ramesh Kesh. I represent Milliken and Company. Been there for 28 years. Ran the research division for a very long time. And I was telling Charles, I've gone to the dark side, so I run 2 business units now. But still, products and sustainability is very close to what we do. And Polartec is one of the business units I run, which you all know about. It's leading in a lot of ways in how we drive sustainability, not alone in textiles, but also in chemistries and outdoor apparel in general.
Now, Polartec is the biggest brand name within these halls. We know that. They're the second biggest brand within the outdoors. We will argue whether you should be the second biggest brand or not. And Polartec is not fleece. It is base layer, it is insulation, it is soft shell, yep, and it is hard shell. But what I do want to start off with, Ramesh, is the work that you've done towards hard shell, towards membranes. You guys are here with Biolon.
Yeah.
Please reveal a bit more about Biolon. And what I want to know is, as we've talked before this, it's a stepping stone to even better.
Yep.
How have you been able to change it? Why can you not make the big leap to the wonderful solution straight away?
Yeah, so I think being the sustainability leader and working for a parent company, Milliken, that is driving sustainability in multiple industries, the important thing for us to start looking at the products we make and how does that impact for the future generation. Sounds very simple, but at the end of the day is you got to really understand every input that goes into making the product and how does that impact the carbon footprint. Not to make noise in the market, but realistically, do you feel every day when you look at yourself in the mirror, you made some contribution towards that end goal? So if you think about that in a bigger sense, every new product goes through a sustainability assessment. A lot of people talk about it. We really do it in the sense is it does not get passed. We don't put a penny on it until it really meets our expectation. So weather protection is an important area, and y'all are very familiar with everything that happened with PFAS and the impact it has in the market, right? That was a disruption started back probably 8-9 years ago, believe it or not, trying to really address what that means, right? If you leave the emotional component out of this, there is science associated with it, and you can argue like climate on one side or another on a given day. But the question really for us is, why do we use certain chemistries in textiles? It's because we have this Band-Aid approach of fixing problems and hope it goes away, rather than going to the root cause of why we need it. So when we started looking at our products, weather protection was one of the areas we looked at, not because PFAS was going to eventually be on the radar, but realistically looking at it in the sense is it was majority electrospin membranes, PU membranes, solvent cast films, and things like that. So the question was, if you really want to address the main problem we are trying to deal with, keep the person comfortable, don't let water ever go in. There are better ways to doing it, right? The industry is way behind in really looking at how you can make that sustainable as well. So overall, when you look at the picture and try to understand what the carbon footprint is going to look like on the future generation products, this was the first one we picked up, and we said there is more opportunity here to replace, in other words, I use the word sequestering CO2, rather than realistically going and looking at materials that are more sustainable. Let's think about the basic carbon cycle. And I'm going to jog your memory going back to your high school, right? There are 3 reservoirs in this world that actually maintains the CO2 balance. And we, as a human race, in the last years, because of industrialization, have started tapping into the reservoir called the lithosphere, where all the fossil carbon that has been trapped there for millions of years have existed, right? We take the coal, we take the oil, and we try to convert it into energy. What have we done? In the due process, we create more CO2 than the natural cycle can even bind to. So CO2 is just a compound. It's not evil. But we have made it into it because we don't know the difference between a bad CO2 and a good CO2. So if you can tap into that CO2 that exists today, that's part of the natural cycle, and take a pivot and prevent it from going back to the atmosphere, that's where bio-based materials comes in. This is not about PLA. This is not about corn. It's about taking that biomass and converting into compounds that we can substitute and shut the tap on the fossil fuel a little bit so that we can prevent the inevitable of putting more CO2 in the atmosphere. So the membrane technology that came about was doing exactly that, taking biomass from a non-human consumption plant, converting that into a compound that eventually gets converted into, which is the building blocks of all the polymers. So you end up with a material that is 50% less on the carbon footprint because all you have done is you did not generate any CO2. You took the CO2 that was already existed, right? And as a result, if you think about scope 3 emissions, you're off the bat 50% less than what the other options are in the market, right? Now, the challenging part in this industry, I think somebody mentioned earlier, was we've got so much used to performance that we're not willing to trade off on performance. I mean, you can't even talk to anybody that you say, I have a better sustainable product. It's end of the day, its performance is a little bit worse than what you have. The chances are very low. So we also challenge ourselves to improve the performance in 2 respects. One is weatherproofness, which means your waterproofness, and also MVTR, which is the amount of air that actually transfers the moisture that goes outside your system. So it is possible. I think we have got 2 products in our booth. Happy to talk to you later on. Don't want to market here on the stage. But it is possible to make bio-based materials, shut down your fossil fuel dependency, and have a renewable bio-based that too, and end of the day, meet the performance expectations of what the market is used to. It is possible, but it takes the will to do it, right? So that's basically what we have done on the 2 products you're going to see. And it does not have to depend on human food. It's a non-GMO. So biomass exists today. How do we take advantage of that and sequester that CO2 is the challenge we went after.
Now, if this conversation is starting to get above your heads, the guys who know me know Charles likes to dumb it down to make it really understandable. And a couple of months ago, they were stretching me. In fact, 6 months ago, we had this foolish person called Eric who rattled all these figures at me. And I suddenly realized how much I didn't know. And when a Frenchman knows more than a Brit, it motivates the Brit to get off his butt and to find out. And essentially, there's so much carbon in the world. We can't get rid of the carbon. It's here. If we let the carbon float free, it forms carbon dioxide, it forms methane, it forms greenhouse gases. But we can sequester, or we can grab the carbon and we can store the carbon away from the atmosphere. If we can take on the greenhouse gases, it's one of the challenges towards the climate crisis. Now, I know that I'm approximating this. So what we're seeing is carbon which from fossil fuels, essentially, when it's burnt, when it's turned into materials, we're sequestering that and we're reusing that carbon. Now, there are several ways to do it. The biomass thing that particularly appeals to me, I've done a lot of work in what's called regenerative agriculture, which Patagonia, the VFs, Hyatt's, Allbirds, Stella McCartney's all working with at the moment. We all remember when we went to school and we did photosynthesis, which is carbon dioxide goes into a plant and oxygen comes out. None of us at the age of 13 asked the question, where does the carbon go? We were just interested in the oxygen. The carbon actually forms the foliage, the plant leaves, or it goes into the roots. This is really simplistic, okay, before you fire dirt at me. That is where we are talking a bioplastic. We're talking here about carbon which has been sequestered in plants, and we're using it, because if we burn those plants, it will go back into the atmosphere.
Correct.
Without making it too simplistic, that's fair.
That's about it, yep.
Okay, so it leads me to the question. I want to ask you later about moisture vapor transmission rates, but can I ask you the question? You're 50% there. The product which you're showing here is 50%. How come you've not done 100%?
So
is this a part-time solution? Are we going to embrace it and suddenly find out someone's going to do something better?
So I would answer it a little differently. I think the industry, when I say just not textiles, chemical industry in a lot of ways, is always try to find an easy answer, right? If you can drop in a certain product and have the same level of performance and at the same cost level, it's a much easier proposition to do it, right? So I think McKinsey did a really good job probably a couple of years ago and defined like 3 product categories when you think about biomaterials, right? It's things that are drop-ins. Unfortunately, from a textile point of view, it's very difficult to do because God knows there are hundreds of shades of black that we got to match in textiles, right? It's not one black. So if you think about color matching and trying to substitute a chemical and match all the shades of it, it becomes really difficult to do a drop-in and expect the same results. It's not possible. So bio replacements is the route the sequestering is going, in the sense that if you look at the backbone of the material itself, part of it is plant-based, the other part is still fossil fuel dependent, right? So I give an example of you first need to crawl before you start to walk and run. So we are in the crawling stages in a lot of ways. So the first product is essentially that 50% level. The product, hopefully everything goes well and stars align by next performance days, we'll have a product that is about 100%. But the challenge is as we go every step of the way, now you're touching the chemicals that goes into dyeing, finishing, and everything else, and you cannot use the same materials you have used before, but this gives us an opportunity to think about how more sustainable can you become the back end of the process as well and fix that. So that is taking a longer time than actually the chemistry itself to fix the whole process, because you just want to do it once, not go back and go in a loop. So people are working on it, need to have some patience.
So when we got into the detail of the conversation, these were things that I didn't appreciate. As someone who does beauty, I didn't understand the technicality. But the dyeing becomes a real problem. We have learned how to synthetically apply to fossil fuel stock, not to bioplastics, not to biomass. And that's causing great problem in an industry that sells itself off its aesthetics. But what surprised me was when I then questioned you about the DWRs, which is an industry norm. We know it's one of the 4 variables about how garments work, the waterproof permeable garment. Tell me what you said about DWRs.
So for example, the weather protection product we have, Power Shield, it does not require a DWR because water is never going to go through it. So end of the day, if you're okay with the wet look of a fabric, which is again a paradigm shift in the industry, you can still wear it and never get wet. It's still breathable, right? So a person wearing it and going through a strenuous activity still is not going to get, even standing in a torrential rain, you're never going to get wet. But the question is, are you okay with the look of your garment because it's going to look wet? It's going to dry out. We still haven't crossed that paradigm, right? The customers still want to get away from that wet look, so you utilize a non-PFAS-based DWR right now. Hopefully, as we get more cognizant, as we get more about learning how to make products that are more sustainable, we'll walk away from those type of technologies. So remember I said Band-Aid approach. Trying to fix a problem by creating another problem is how we have been going and working around. So why don't we fix the root cause of all we are trying to do is prevent water from growing in? There are multiple ways of doing it.
And on that subject, it brought me back to what I was saying this morning when I did the focus topic introduction on membranes. Something I've really noticed on membranes is when microporous membranes have their face fabric wetted out, their permeability really sinks, whereas hydrophilic doesn't. So without making too much of a song and dance,
Yep.
what you have is a polyamide hydrophilic system.
Correct.
Why do you prefer that? Or is the door still open? Because you used to have NeoShell, which was an electrospun.
Right.
What are you seeing is the difference within your customer base, within the audience, of you changing a membrane?
So there is definitely an education component, right? You think about this weather protection area, it's been dominated by certain companies, right? And for a consumer who goes buys a jacket, do you think he really cares about 20,000 millimeters of water resistance? No, none of us really need it. But why are we pushing something that is really not required? You're not in the special forces for you to be.
Because we live in a numbers society and we think the greatest number wins.
So the education component is important. So we've gone through a little bit of that. I think the second part also is to the fact that you tell somebody what waterproof really is, until they try it, it's impossible for them to really understand what that means. Because most of the time, the water leakage that you see is because of the leakage through the seams. It's not through the fabric. And then beading up using, we cannot replace PFAS. Let's be honest with it, right? For you to really get close to it where water starts to bead up, does that make you feel better? Or are you interested in not getting wet? And at the same time, having a material that's breathable. We got to ask ourselves the fit, form, and function question first. And there is an education component that has to go with it. So, we've got brands accepting it, and we are in production with the product. And end of the day, it is still, I think, we're not done with the conversation part. The education has to happen. We got to really make sure they understand what's that function that you're going after, right?
Now, just to round up on membranes, I know we're very focused on membranes, but the waterproof breathable jacket is the most iconic product of this industry. We're talking about measurement systems, and you were talking about moisture vapor transmission rates. We have other ways to measure.
Right.
I came right up to speed. I know there's someone in the audience who knows more about DMPC than me. Why? I know it creates great consumer confusion,
right,
that we're all using a different system. Why MVTR?
So, there are different measurement systems, but you look at, in fact, most of the study trying to understand, because some customers ask for air perm, some ask for MVTR, some say you just need air perm, but then you ask about, okay, what pressure are we talking about? Because the word air perm is ambiguous enough to the point, what pressures are you talking about? They say ½ inch of water. For those who really want to comprehend that, if you're wearing a jacket and you're in a bicycle driving, you're riding at 30 miles an hour, do you think the pressure differential between your garment and your skin is big enough for that air to go through unless it's permeable? It's not. So why are we defining things that are so ambiguous to the point where then you start putting a number? The number should mean something, right? And that's the part where we look at it and say, okay, ½ inch of water is really not how you measure it. Let's go and define something that is a little more realistic. And based on all the real-life data and some of the things that we have done, I think U.S. Army has done most work than anybody else that you can imagine on different garments that's in the market today. And MBTR seems to make a lot of sense for us. Obviously, we measure RET, we measure air perm, we measure everything. But for us as a brand, ingredient brand, to talk about what is important to the end user, that makes a lot of sense for us, right? Based on the space we are in at this point.
I think I'm more bringing up the subject because one of Charles's bugbears is that I know that if I put the question out to this room, there are two people sat in this room who can tell me the difference between RET, MVTR, JIS, JIS inverted. Are there any other ones I've missed off the list? The point that I'm making is that we don't understand it as an industry properly enough. So how our consumer can make headway through it, I think we're just causing confusion. We have complicated our own back. But I want to move off membranes.
Sure.
Because whilst I've got you on stage, we can't take all day. Polartec have also done something stunning. You're most associated with fleece.
Right.
But you actually have led the way in shed-less fleece.
Correct.
Can we have an update, please?
Yeah, I mean, there's...
The update I really want to point the finger on is that you've not gone down the biodegradability route.
Absolutely not.
Why not?
So the word biodegradability is even more ambiguous to me. Biodegradable under what conditions, right? We all have lived through PLA for 30 plus years now. You know, it's slowly starting to take. But biodegradability is not defined by the source of the material. It defines by the structure. So in order to make a material biodegradable, our grocery bag industry has tried it for years and years using so many additives that you can put in there. End of the day, we know it doesn't work, right? So the question is, if you have a material that's biodegradable, and it is existing polymers that we know of, what happens to the material when it degrades is the question, right? By putting additives in there, you cannot change the fundamental chemical structure of that material and the degrading mechanisms, right? Take polyester, for example. Hydrolysis, we know exactly where it breaks. The weakest link is the ester bonds in there, right? Chain cleavage is where it breaks down.
I just nod to pretend I know what I'm talking about. If you're the same.
So the question is, are we making more microfibers is the question. Because we have spent over 4.5 years, I think there are a lot of people in this room probably did as well, trying to define a test method of how you measure microfiber shedding, right? We know every fabric sheds, but I think the bottom line is trying to come to address why it shreds starts all the way back from the yarn. And then the test method itself measures the increase in the weight on the filter. Now, the thing that you really, if you run hundreds and thousands of this test when you look at it, it's just not the fiber that shows up in the screen. It's the dyes, it's the finishing chemicals, there's a whole bunch of other stuff shows up, right? So in order to really avoid or minimize the amount of shedding, you've got to go back to the yarn level and start working forward. So the product that we introduced for fleece called Shedless, using the AATCC test method, you can reduce shedding by about 85% with that material compared to our own predecessor that we have. Now, the shedding number is extremely small, but we know how big of a concern that is. So I think we have taken a fundamental approach and gone back to the root cause of why that fiber is separating out and how do you make the yarn. And eventually, when you have a fleece and you wash, and the test method is predictable compared to what we used to have before. So now you can actually realistically compare different fabrics and see what your shedding level is. So Shedless is our technology, and we started with fleece. Obviously, we know right now it is still, we are sampling to customers. Customers are verifying the results. We're not in production yet because, to me, this is an R&D project that trying to get the proof of the pudding on the technology now before we launch it, because the next question is, why can't you apply this on all other fabrics? And we are looking at that right now.
Now, I want to bring this to a close so that we have a chance for audience questions, if you guys want a question. What I haven't told Ramesh is that in the audience, we've also got the guy who wrote the Microfiber Consortium test method.
Good.
So beware, all right, what I'm saying.
Yep.
I'm not going to dive into something else I found out about Milliken, was their ability to do flame-resistant fabrics. I didn't realize they were so big in workwear. So at that stage, Charles just went very quiet and started to take a lot of notes to do with workwear. But initially, can we show our appreciation, please, for Ramesh for being so open about their research? And then, questions. Who wants to take on Ramesh? You've got your opportunity now. And it's more to do with either the technical ability or the direction that one of the big brands is working within this industry. Now, I can easily fill in, but I know there's some people in this audience that might well want to ask a question. Ramesh will be to the side of the stage afterwards if you want to do it on a one-to-one basis. But would anyone like to kick off with the public questioning?
Yes.
I'm bringing in the microphone. Perhaps I should say this is Dr. Mark Taylor.
Loads of us in this room. Oh yeah, thanks for that. It's really interesting. I do take a bit of issue with the idea that if the outer fabric on a waterproof wets out,
Yeah.
your membrane still breathes. Because where do the water vapor molecules go as they pass through the membrane? If the outside fabric's sodden wet, they can't go anywhere. So breathability is massively reduced or stops depending on how wet. And, I've done lots of experiments in this area. It's not theoretical. And I know somebody else in the room has as well.
Yeah. So I think you probably, if you're thinking about hydrophilics in general, the polyurethane-based hydrophilics 100% agree with you, right? So end of the day, the way the diffusion mechanism happens, if it is dependent on the concentration gradient of moisture on both sides of the membrane, 100% agree with it. But our hydrophilic is essentially works on 3 different mechanisms. I can talk to you one-on-one later. So most of the things we have done is trying to adjust the humidity level on the surface of the fabric, change the temperature levels, and even some cases we have soaked the membrane for about 6 to 8 hours and looked at the MBTR changes over time, right? And what you find is sometimes even microporous membranes, they just drop big time when the humidity levels increases. So it comes down to the actual material and how it handles it.
So if you think about the membrane in isolation,
Yeah.
absolutely. It's all down to temperature gradient.
Right.
It's not even about humidity gradient, really. It's more about temperature with the humidity messing about with it. And yes, if you wet the inside face of a microporous, it won't, moisture can't move and the pores are blocked and the hydrophilic will still suck the moisture through. But when you stick a face fabric on and that face fabric is saturated, the water molecules that are coming through the hydrophilic stepping stones, they can't get out on the other side because it's wet. So then it can't keep moving moisture until it starts to dry out, and then it can start to. And that's where I'm a bit puzzled.
Yeah, so there are multiple gradients based on which the water transfers. If you just think about Fick's law, you think about Henry's law, end of the day, what you're trying to do is the ability to swell that film itself determines how much of moisture that's getting transferred from one side to the other. So hydrophilic doesn't necessarily mean that you're going to, if it's a monolithic layer, you're going to completely stop it.
Before we get too technical, we've lost Dr. Katie Stevens. And I actually wanted her input from her PhD work. And she pointed, you know when someone says something really obvious and you think, why didn't I think of that? She talked about on garments, we're moving the whole time. And a vast amount of moisture is being shed through the movement of our garments. So I'm not prepared to say that's the answer, because it wasn't my PhD. But I am suggesting there are more than one factor that come into it. Mark, how would...
No, I mean, I was involved in Katie's work and worked with Andy Spink before that in a similar area and with Matt Morrissey since. And the problem with concentrating on MVTR as a really important property for garments is what we just talked about. When the outside gets wet, breathability drops off. So when it's raining and your DWR's not working, or even when it is, the breathability decreases. And I hate calling it breathability. You put a bag of your membrane over your head, you'll probably suffocate.
Yeah.
So it's not breathable, but let's... and the reason we don't get lots of condensation forming in garments normally is that we don't close all the vents and all the zips. But when we do, condensation probably becomes inevitable. And so Kate is right. So people like Andy Spink, whose products disappear now, but his outer was completely impermeable. If you build a garment that vents properly, you don't need a moisture vapor permeable layer. It just works. If you design it properly and the air can move around and you get sort of like bellows ventilation going on as you move, it pumps the air around.
So I think I can answer this way, Mark. I know it wasn't the question. So there are reasons why they put vents on some of the garments, right? So far, the customers who have adopted our products, there are no vents in them, right?
It wasn't just about vents. It was designed with a reticulated foam liner, so air could move around inside the foam. That would then carry the hot, moist air out up through the neck, maybe out through the vents if you had them, allowing cool air, dry air to move in at the other places. So it's about getting. It's not just about sticking vents on a garment. There's more to it than that.
I would also say Andy Spink's garment, I know, and it was for a cyclist. So there was a headwind with the generation of a good flow of air coming through the garment. But we do have a different question. Ulrich.
I think we are sticking all on the question how we make a jacket, a waterproof breathable jacket, better. Yeah. So, but why not we sit down and think what is working for the consumer the best?
Right.
And for example, for me, everybody or many people know I made a lot of success with waterproof breathable jacket. I made the first double jacket in the world. And however, to me, I think all those products are not necessary. What I'm using personally nowadays, after more than 40 years being in the business, I have a jacket, it's called Storm Fleece. And it's a very tight woven fleece. And it's very abrasion resistant and outside. And it's water repellent, very good water repellent on the outside. So with this jacket, I'm not sweating at all. It's fantastic. I can go up a high mountain, 1,000 meters. And of course I'm sweating, but I don't feel the water, the jacket is not wet inside.
Correct.
So, and if there's a little rain, this is enough. If there's a pouring rain, I don't have a jacket. I have a poncho. I have a poncho over me, which covers even my backpack. It covers everything. It covers down to here. So we always want to sell jackets. We are stick on that. We always take it as a religion, but we don't think what is best for the consumer. And I want to ask you, what do you think about this combination? What I'd use, I really, after so many years, my Storm Fleece jacket plus the poncho is the best solution. I know this is a provocation, but I want to put it on the table.
So remember I said fit, form, and function, right? And the consumer needs to define what the performance level is. Trying to go and improving these numbers higher and higher because somebody else does in the market seems to be the trend. And that's not where we play. If you look at our collection, actually, we don't have one performance level products. Depending on if it's cycling, it's going to be something else, right? What that end user really needs is the question. So let's not hit the numbers and keep bumping it higher and higher and calling it better performance products. Let's talk about what the end user really needs. So 100% agree with your comment.
You see, I had a completely different approach with Ulrich. I am very happy with what you've described, but if it's going to rain harder, I don't go outside. I think that's something to do with my age at the moment. We're going to blow the time, unfortunately. So not only has Ramesh been open about the philosophy to the research, I think he's taken on a few questions. Currently, I think we would all agree there is not an easy solution. What I do know is what we have at the moment is not good enough. Legislation is changing it. We must change. We must catch up. And actually, perhaps those people with better thinking are going to lead the way. But can I ask you to show your appreciation for Ramesh, please?
Thank you.
Ramesh, in fact, if you go to the back of the area there, if anyone wants to speak to you on a one-to-one basis, they will catch up.